Okay, now let's consider a more interesting example that I've taken from my colleague Stefan Leboeck. Let's imagine now that we have Luke Skywalker, who is on Dagobah, the planet Dagobah, and Han Solo is on the planet Tatooine, and halfway in between, Princess Leia is on Alderaan. So Luke and Han have a Luke, Han, and Princess Leia have a long-standing lunch date. They like to meet on Alderaan, halfway in between, um, at a particular time of day, and they like to get there at exactly the same time. So if Luke calls Han precisely when he's leaving um, Dagobah, and his X-wing fighter travels at a maximum speed of c over 5, the 1/5 the speed of light. Then the question is, how fast does Han have to travel after he receives the signal? By when I say call, I mean he sends a light signal. So how fast does Han have to travel after he receives the signal in the Millennium Falcon for them to arrive simultaneously at precisely the same moment at Alderaan? Okay, so the first thing to do is to draw a space-time diagram. Okay, and I mean that's how we're going to figure this out. And so what I've done first is I've shown the you know CT on the vertical axis, X on the horizontal axis as usual. I've drawn the world lines, the vertical world lines of Dagobah, the planets Dagobah, Alderaan, and Tatooine. In this reference frame, they're stationary, so they don't have any change in the X coordinate. The distance between Dagobah and Tatooine I've denoted as L. Okay, and so the distance between Dagobah and Alderaan and Alderaan and Tatooine is L over 2. And one of the cool things about a space-time diagram that emphasizes this sort of geometric properties is that since the vertical coordinate is CT, which has units of length, then you can mark off equal units of length that have the same scale as the horizontal axis. So for example, this distance here is L over 2, and that same distance in the vertical axis is also L over 2. Okay, so the first event that happens over here is that Luke leaves Dagobah and he sends a light signal, a message to Han, and we're gonna that starting event has coordinates 0, 0 in the space-time diagram. Now, it's important to remember that even though there are two distinct things that happen here, he leaves and he sends a message, because they happen at the same point in time and the same point in space, they're a single event. Okay, so I've marked that event down here, event A, as at the origin. Okay, so now what we want to do is we want to figure out how long it takes Luke to get to Alderaan, and how long it takes the light signal to get to Tatooine, and then if you subtract those two, obviously you'll get the time that Han has to get from Tatooine to Alderaan. So let's just remember that the definition of beta is right here, and write a change in coordinate, a spatial coordinate, is related to a change in time just by v. So delta x is equal to v delta t, and v in this definition is just beta times c. Okay, so this is just distance equals rate times time. Okay, so if we just rearrange this, then we have that the change in the coordinate, the change in the vertical coordinate c delta t. If you know the change in the spatial coordinate delta x, and you know beta, the speed, then you can get the change in the vertical coordinate just in this way. Okay, so for Luke, he's traveling at 1/5 the speed of light, and he has to go L over 2, the distance to Alderaan, and so plug that in, and c delta t equals 5 L over 2, and so he arrives at Alderaan precisely at this event c denotes his arrival at Alderaan, and it happens at time 5 L over 2, and it happens at position L over 2.